Welcome to our notes on polar coordinates. Students will be able to plot a polar coordinate and convert between polar and rectangular coordinates. Part 1. Read and mark up the following text. I will not mark up the text because I want you to mark up the text based on what you think is best to mark up. So vocabulary is always a good thing to mark up or to make notes on. So far you have been representing graphs of equations as a collection of points x, y on the rectangular coordinate system. In this lesson, you will study a new coordinate system called the polar coordinate. Polar coordinates specify the location of point P in the plane by its distance r from the origin and the angle made between the line segment from the origin to point P and the positive x-axis. Then each point P in the plane can be assigned polar coordinates r, theta as follows. Number 1. R is the distance from point P to the origin, or the radius. Theta is the directional angle from the positive x-axis. To plot a polar coordinate, step 1, locate the angle on the graph, and step 2, move the point to the correct radius on the graph. We're going to do that on the next page. Part 2, show your comprehension of the text from the previous page by plotting the basic polar coordinate points. Use pencil. So do not highlight anything right now unless you really want to. I'm going to show you a couple of things about this graph. I'm going to mark it up first so that we can understand how we read it. So this first circle right here has a radius of 1. Okay, this second circle has a radius of 2. And the next one has a radius of 3, the next one a radius of 4, and I can like go on forever, but we're only going to go up to 5. So now I'm going to take that off. Now, what are these spokes, if you will? Let's label. So we need our angles here, and we're going to be in radians. So this will be 0 or 2 pi. We're used to this. This is pi over 2. This is pi, and this is 3 pi over 2. All right, so I'm going to label the first quadrant with you, and then I'm going to pause the video and label the rest of this so that you can copy it down. These lines are actually going up by pi over 12 increments. So the first line would be the angle pi over 12. So from the positive x-axis to that line, this line segment, if you will, that's pi over 12. The next one is 2 pi over 12, which actually simplifies to what we're used to seeing, pi over 6. The next one is 3 pi over 12, which reduces to pi over 4. Then 4 pi over 12, which reduces to pi over 3. Then 5 pi over 12, that doesn't simplify at all. And then pi over 2 is the same thing as 6 pi over 12. So I'm actually not going to write the, pi over 12 ones anymore. I'm just going to write the rest that we're used to from the unit circle. But that is how you read this. So I'm going to pause the video, finish labeling the rest, and then we will plot these 5 points. All right, so here's the rest of the label coordinate system. Now I'm going to graph these points. So point A says it's 2 comma pi over 3. So the first step is, I'm going to highlight this now, but I'm going to erase this, so don't highlight. The first step is to locate the angle. So I'm going to locate the angle pi over 3. Here's pi over 3. So I'm going to be on this green line right here. I'm going to go ahead and get rid of that. And now I need to graph the radius of 2 on that pi over 3. So that would be right here. So I'm on the circle with the radius of 2, and this is the angle of pi over 3. So this is point A. Okay, so I'm going to graph a little bit faster now. So now point B is 1 comma 3 pi over 4. So I'm going to find 3 pi over 4, and then I'm going to put a dot on the circle with the radius of 1. So I'm right here. We'll label that B. Point C is 3 comma 11 pi over 6. 11 pi over 6 is here, and then the radius of 3 is right here. Point D is 3 comma negative pi over 6. So if you remember coterminal angles, we can just add 2 pi to get to an equivalent angle. And negative pi over 6 plus 2 pi is 11 pi over 6. So C and D are in the same positions. All right, so point E is very special because this has a negative radius. So how do we graph that? We're still going to find our angle first. So our angle is pi over 4. I'm going to highlight that. So instead of being here, which is, I'm going to label this point F. Point F is positive 2 comma pi over 4. So instead of being here, I'm actually going to swing backwards. So I'm going to highlight this angle. So if I was at pi over 4 and I added pi, I would be at 5 pi over 4. I'm going to graph this one instead. This is where point E is. Negatives just tell us direction. So if I have a negative radius, instead of going on the the line segment of my angle, I will swing it backwards. And that's all that's saying. So how to plot a polar coordinate with a negative radius. Step 1, you locate the angle on the graph, and step 2, reverse the direction and move your point to the correct radius. Okay, so make sure you reverse the direction. That is key. Part 3, converting from polar coordinates to rectangular coordinates. So here's a verbal I want you to read and mark up. It says, when we use polar coordinates and Cartesian coordinates, the pole is the origin and the polar axis is the positive x-axis. By applying trigonometry, we can find equations that relate polar coordinates r, comma theta, and the rectangular coordinates x, comma y, or a point P. By the way, Cartesian is another way of saying rectangular. So rectangular coordinates, Cartesian coordinates are the same. So here we have a very familiar diagram. We have, a circle centered at 0, 0. We have a line segment that has a radius. We don't know what it is, but we have x and y and theta. And we've seen this multiple times, so this is going to be very simple for us. So let's come down to the algebraic. It says, write a set of equations that represents the conversion of polar coordinates to rectangular coordinates. All right, number 1 says write x in terms of r and theta. So the relationship between x, r, and theta is this. Cosine of theta is x over r. And I want to get x by itself, so I'm going to multiply both sides by r, and I will end up with r cosine of theta. Number 2 says write y in terms of r and theta. So sine of theta equals y over r. So if I solve for y, I get r sine theta. So putting this together, x comma y converts to polar coordinates by me doing r cosine theta, r sine theta. All right, so let's work with these 2 points right here. So part A says 2 comma pi. I want to convert from polar to rectangular coordinates. So the way I'm going to find x is I'm going to simply do r cosine theta. In this case, r is 2 and my theta is pi. Well, if you remember your unit circle, this will be -2. So my x coordinate will be -2. And y is going to be r sine of theta. 2 sine of theta is actually going to be 0. So having x and y there, my rectangular coordinate is -2, 0. Okay, part B. I have the square root of 3 comma pi over 6, so x equals r cosine theta. R is square root of 3. I have cosine of pi over 6. That is just going to be root 3 over 2. When I multiply root 3 times root 3, I get just 3 over 2. And so I'm just going to write it here because I realize I don't really need that line there. Y is our sine of theta. So this is root 3 times sine of pi over 6. Well, sine of pi over 6 is 1/2, so this is going to end up being root 3 over 2, and this is the equivalent in rectangular coordinates. Part 4. Converting from rectangular to polar coordinates. So this is the exact same verbal and diagram from the previous page, so I'm just going to go right to the algebraic. It says write a set of equations that represents the conversion of rectangular coordinates to polar coordinates. All right, number 1, it says write r in terms of x and y. So to relate these 3 letters here, if you go back to the diagram, we have a right triangle. And so here we think Pythagorean theorem. So x squared plus y squared equals r squared. That is also the equation of this circle because it's centered at 0, 0, and whatever r is the radius. So if you square root both sides, you get the square root of x squared plus y squared. But this time we're actually going to use the plus or minus. Number 2 says write theta in terms of x and y. Well, we have that right triangle there, and the relationship between x, y, and theta is that tangent of theta is y over x. So to get theta by itself, you take the inverse tangent of both sides. So inverse tangent of y over x will give us our angle. Okay, so here's part A. It says find 2 equivalent polar coordinates for the given rectangular coordinate. So what we're going to do is we're going to have a positive radius and a negative radius version. So I'm going to draw a diagram just to figure out which quadrant I'm in. So -1, 1 is somewhere here. And so I'm in my second quadrant. Now that I know that, actually I'm going to make this better. Now that I know that, I'm going to find the r value. So r is plus or minus the square root of -1 squared plus 1 squared. That's going to eventually give me, sorry, I forgot the plus or minus, square root of 2. And now theta, I'll tell you what to do with the plus or minus in a moment. Theta is going to be inverse tangent of 1 over -1, it's y over x. 1 divided by -1 is just -1, which means I'm at -pi over 4. But remember, -pi over 4 is in the 4th quadrant, so I have to add pi. So I'm going to go -pi over 4 plus pi. That will put me where? That will put me at 3 pi over 4. Okay, so the positive radius, the positive square root of 2, is going to go with 3 pi over 4 because 3 pi over 4 puts me in the second quadrant, not -pi over 4. Now, if I were to go to -pi over 4, I would have to reverse the direction. And when I reverse the direction, that means my radius is negative. So these two puts me in the same spot on the polar coordinate graph as this point -1, 1 on the rectangular graph. Part B, 0, 2. So first I'm going to draw that. 0, 2 puts me here. I can see clearly though, I don't really need to do any algebra because r is just 2. You can try doing the square root of x squared plus y squared if you want. You're still going to have the radius of 2. And just to be consistent, I'm going to do the plus or minus 2 here. And theta I can see is pi over 2. So with the positive radius, I'm at pi over 2, right? The other way I could go is to go down to 3 pi over 2 and then reverse my direction so I can have these two equivalent expressions. We're going to practice this more in class. But let's go on to part C. Before I continue, I actually went ahead and drew lines from my point to the origin so that you can clearly see that you're going to find that distance, which is the radius, if this appeared on a circle. So we found our radius is plus or minus square root of 34. So I know I'm going to have the positive square root of 34 here and the negative square root of 34 there. Let's find our angle now. Our angle is inverse tangent of negative 5 over 3. And make sure you're in radian mode. That is going to be negative 1.030 if I stick with my 3 decimal places. Now, this angle actually does put us in the 4th quadrant, which is where our point is. So I'm going to use that with the positive radius. To get to the other one, I must add pi. So if I'm going to use the negative radius, I need to add pi to this. And when I do, I get 2.111. Okay, so if I first go to the radius of 2.111, which is actually on this side, okay, and then use my negative radius, then that will swing me back into the 4th quadrant.